Okay, this is lesson 9.4. Anytime you have, if you don't know the population standard deviation and your sample size, either one of your sample sizes is less than 30, then you have to use a t-test instead of a z-test. We're back to doing means again, notice. We're not doing variances, now we're doing means. Okay? But if you read the textbook, it's going to tell you that you have to figure out if the variances are equal or not first. So it's going to tell you in the textbook, you have to do the f-test first, just to figure out which t-test to use. Okay? Well, I'm not going to make you do that, because that's going to take a lot of time. We just did a whole assignment over doing the f-test. What I want you to do is always assume that the variances are equal today. All problems on this assignment, you can assume the variances are equal, which means you can assume that this is the formula you're going to use today, your test for your test value. The one major change will be the degrees of freedom are no longer n minus 1. But I want you to notice this. If you took the first sample size minus 1, and then the second sample size minus 1, and then you combined them by adding them, what would you get if you combined these? Would you get this up here? Yep. So if you take n1 plus n2, then minus 1 minus another one, that's like minusing 2. So really, since you have two sample sizes, you're going to add the sample sizes together, and instead of subtracting 1, you're going to subtract 2. So that's how you're going to get your degrees of freedom. All right, let's do number 1 on lesson 9.4. This will be page 492. We're going to do the traditional method of hypothesis testing. A real estate agent wishes to determine whether the tax assessors and real estate appraisers agree on values of homes. A random sample of the two groups appraises 10 homes. The data are shown here. Is there a significant difference in the values of the homes for each group? So you go to maybe First State Bank, have a real estate person come out, and he tells you what he thinks your home's worth. And then someone from the county comes out because they want to make sure they're charging you the right amount of tax on your property, and they also look at the value of your home. What we're trying to see is if these two people would agree or not. Okay? Here's my data, and we're going to start on the left with real estate appraisers. And they're going to say that the average income, or the average value of the homes they're looking at, is $83,256. Or the tax assessor, which is our sample 2, the average value that he valued those homes is $88,354. What we're going to be trying to figure out is, are these close enough that they would be considered equal statistically? That maybe the difference is just due to sampling error, depending on which real estate agent we picked and which tax assessors we picked, okay? Or are they far enough apart that we can say, hey, it looks like tax assessors definitely value homes differently than real estate appraisers. All right? Sample sizes here. Looks like we have, actually, the first sample size is 10 homes, and our first standard deviation is $3,256. Our second standard deviation, $2,341. And our second sample size was 10 homes again. Okay, let's start with letter A, our null and our alternative hypothesis. Is there a significant difference in the values? So it sounds like to me they're claiming that there is a difference. They're claiming that the mean value given by all real estate agents is not equal to the mean value of homes given by all tax assessors. The number would be that they would be equal. Any questions about that? It's an interesting question when we own a home. When two different people come out and tell you that your property's worth different amounts, and you're going, okay, which is it? All right? Of course, why would a tax assessor want to say your house is worth more? Pay more taxes, yeah. I hate it when the tax assessor comes to my house and tells me my house is worth more. I love it if the real estate agent does that, because that means I can sell it for more. But when the tax person comes, I don't like that, because then I can pay more taxes. So When the tax person comes, you're hoping as a homeowner that they'll value it lower. When the real estate agent comes out, you're hoping they'll value it higher because you want to be able to sell it for more. So there's different purposes here. That's the reason we probably see differences in numbers. Okay, anyway, let's keep going here. Traditional method says next you look up the critical values. So we're going to be looking at a T distribution here. We're going to look at a two-tailed test. So get your T chart out. And it's two-tailed. These are my critical values. And what's the degrees of freedom going to be? Try that again. It's different than normal. 18. 9 plus 9, or 10 plus 10 minus 2. So it's going to be 18. 2 samples, so we have to do 9 plus 9, or 18. Okay, so go to degrees of freedom on the left side of 18. Across the top, go to two-tailed, and go to, what's our alpha value? 0.05. So go to two-tailed and 0.05 at the top. Two-tailed. 3.101. 2.101. Anyone else agree with that? Okay. So it'd be negative. Our left critical value would be negative 2.101. Our right critical value would be positive 2.101. Step C, test value. That's where the big formula comes into play. So x bar 1 minus x bar 2. So that's going to be $83,256 minus $88,354 divided by square root of n sub what minus 1. So that'd be 10 minus 1 times your first standard deviation squared, or that'd be your first variance. So that'd be 3,256 squared plus 10 minus 1 again times your second standard deviation squared. So that'd be 2,341 squared. Underneath that entire fraction is n1 plus n2 minus 2. So that's going to be 10 plus 10 minus 2 times, and then you're still going to have, over here to the right, crazy formula, 1 over 10 plus 1 over 10. That's this part of the formula.
Wait, is that underneath the division?
It's all underneath the division, yeah. I think I'll show you how to type this in. The way I would type this in would be in 3 separate parts. And Lucas, you might want to film this too, so that the hardest part, I think, of this problem might be typing it in the calculator. Okay, Gage, can you just shut one light off to this side so we can see a little better? Thank you. Okay, the way I'm going to type it in, I'm going to type the numerator in first. 83,256 minus 88,354. Get that numerator answer. Then let's type in what's under the square root. Now some of this you could do in your head. 10 minus 1 would be 9, so I'm going to do 9 times 3,256 squared plus 10 minus 1 again is 9 times 2,341 squared. Let's figure out what that is. I'm kind of doing this in steps. Go back and forth. Lucas, why don't you go back over here so we can see it down on there. So the top number came out to negative 5,098. Down here you're going to have the square root of...
I got a different number.
Which number did you get different?
I got like 2,835. That's him? Yeah. I must have done something different.
353. And right here, 10 plus 10 would be 20, minus 2 would be 18. I'm going to divide that by 18.
Oh, wait, yeah, I got
times. Let's just do this in our head. What's 1/10 plus 1/10? 2 tenths. Yep, so this would be 2 tenths. Okay. Now let's type in that. So I'm going to do negative 5,098 divided by, and then put this whole denominator in parentheses, square root of 144,736,353 divided by 18. Close the parenthesis because that's the end of that square root. Times, and then square root again, of 2/10. Close your last parenthesis. So I'm putting parentheses in here and here. That way it knows what I want to take the square root of, and it knows it want everything in the denominator there. And I push enter, and that should give me my t test value for t. Anyone else get that?
Yeah.
Okay. So we got a test value of negative 4.02.
Triumphed.
So if we look back up at our distribution up here, our t distribution, where's that going to fall? Left side. Yeah, it's going to fall way over here. Right? Zero's in the middle here. So negative 4, you're over 4 standard errors to the left of the mean. So we're going to reject or not reject the null? Right. Reject the null. Let's see. We're rejecting the null. That means we think the null is false. That means we think the alternative is true. So there is enough evidence to support the claim for step E. There's enough evidence to support the claim that, what was our claim? That real estate appraisers and tax assessors value homes differently? Might be one way to say it. That there is a difference between real estate appraisers' values and tax assessor values, which doesn't surprise me because a tax assessor wants to value a home more. Okay? So there's enough evidence to support the claim that there is a difference in home values given by tax assessors and real estate agents. Something like that would be fine. Any questions about that?
We still have to find the confidence.
Still to find confidence in it. You can turn that off for now, though.